screen there. So, welcome to the first day. I'm going to be talking to you about Bash and introducing you to the Bash shell. This is the underlying interface for a lot of Unix, for all Unix computers. Now, to start off with this, we hope that you've all gone through the process of making sure that you have either Git Bash installed on your computer if you're using Windows, or that you've got the terminal open if you're on Mac or a Linux computer. Please say now, speak now, up now if you haven't. If you have, could you please, in the notes, there is a link to the setup page for the Shell Novice course. And if you can, there's a link to a zip file that we're going to download and open. And this has the material that we're going to use for the teaching today. So if you, on your computer, I'm going to show you this on a Mac, but please follow this steps on your own computer. So download this, save the file. So save that file, and then drag that or copy that zip file onto your desktop and unzip it. And on Mac, I'm just going to double click. So once you've got that done, please put a tick in the in Zoom to show that you've got that data folder. And once everybody has, then I'll move on. And if anybody wants me to go through that again, put a cross or a...
Sorry, where did you want us to put the tick?
You can, if you look, obviously, because I'm sharing, it doesn't show me, but there is an, is it reactions? I think
it's called reactions now, yes, in the latest version of
okay, thank you.
Of Zoom, and it's on the bottom
That's good.
tab with all the buttons to mute and
they don't seem
unmute.
To be very persistent.
So the task is just to download and save it somewhere. This is...
Yeah, so if you put it on the desktop and open it on your desktop. And I don't know how long those ticks last for, so maybe if you haven't got that done yet, could you put a cross on so I know that we need to give you a help?
I think if you can't find it in reactions, it might be in the participants list.
Yeah.
Yes, in the older versions of Zoom, it can be on the under participants list. So just keep, if you finished, just please keep the green tick on, and then the helpers will clean it.
Right. Okay.
Or if you're struggling, just put the red sticky note.
Right. So I'm going to swap to...
Or just speak up if you're having problems.
Yeah. So I'm just going to share my terminal now. So if you are, could you all open a terminal? So this is on Windows. You would run the Git Bash program from the Windows Start menu. On a Linux computer or on Mac, you can search for terminal and open the terminal. This is mine. Is that text readable for everybody. Just want to make sure that it's okay. I can make it larger if needed.
Sorry, but I'm lost already. How do you manage to open that screen from the software?
Which, the terminal or the?
Well, I'm not sure. I downloaded data shell on my.
Okay. So you downloaded it onto your desktop. Are you using Windows?
Windows, yes.
Yes. So if you right-click on that zip file, you should have an extract option, I think.
Well, I already unzipped it, but once I'm there, where do I open it? From?
Right. Okay. If you in your in the program manager, or sorry, from the Windows Start menu, open the program git bash.
Okay.
And that will give you a terminal in the same way, very similar to this one.
Okay, found it. Thanks.
Great. Okay. So yeah. So this, and once you've got that open, if you type in cd, this is your first command. This is change directory. And so you type in cd and press enter, and that will make sure that you're in your home directory, and we can start that lesson. So, okay, so this terminal you have open, this is a command line interface to the computer. So we're all familiar with graphical user interfaces. This is Windows and the Mac systems. These are very common interfaces to use, which give us a very intuitive interaction with the computer. But what we're not very able to do, or what's not so possible with using a GUI, is to enter the same command multiple times to do very organized and large-scale processes. Because on a GUI, you have to go through and manually select options, click on them, step through directory by directory. In a command line interface, you can build up pipelines of work, which you then run, and these will automate those tasks for you. So the most popular command line interface for Unix systems is the bash shell, which we're going to introduce you to today. Now, this is available on most modern implementations of Unix and most packages that provide Unix-like tools. If you're on a Mac and you have a new Mac which you haven't used previously, for this, you will probably actually be on ZSH rather than bash, but the commands should be very, very similar. So I think there aren't any differences for what I'll be teaching today. Now, when you first open your shell, you'll be presented with a prompt. This is my prompt here. Now, your prompt will look different to mine. The main thing is that we have this symbol at the end, which shows that the terminal is ready for you to type in commands. What I've got here as well is I've got my username on this computer. I've got what would be the computer name if my network hadn't renamed it. And also then I've got a bit of information about which directory I'm in. You may have more or less information there depending on what your system setup is. So the first command we used was cd. So this is change directory. The next command I'm going to show you is ls, which is short for listing. So what this will do is it will show you what you have in your home directory, in the directory that you're in at the moment. And I have a lot of junk in there because I've been working on this computer for a long time and have got lots of stuff stored all over the place. You will have similar bits of information. What we should all have is probably a desktop. We'll have documents, downloads, things like this. So there's going to be common aspects to all our workspaces. But what we will now, the other thing to show you is on GUI, if you click on the wrong thing, nothing happens. It will just kind of do something random. If on the command interface, you type in something which isn't recognized by the system, it will tell you that a command isn't found. So in this case, I tried to type in KS rather than LS. So that's a simple slip of the finger, which there is no command like that. It will tell you that it's not found. You then can check what you typed in and make sure that either, if it was something which should be there, you can try and install it, or if it wasn't, you can work out what error you made and correct that. So what we'll do now. So I'm going to start off this morning giving you a bit of an introduction on how to navigate files and directories using the command shell. So to get information about where we are, we first need this command. This is print working directory. So this is going to tell us exactly where we are at the moment. So on a Mac, on OS X, I am in my home directory. So this is my username, and this is the user's directory. So if you could all type in pwd and have a look at where you are. Now, if you're on a Windows computer, you're going to see probably a C: documents and settings, and then your username. So this is because Windows disks are labeled C, D, E, and so on. If you're on a Mac, it will be users. If you're on a Linux computer, it's going to be home. Now, this directory, the file systems and the organization for these computer systems, these are hierarchical. So you start off at the base of your computer system. On a Unix system, that is /, and that is your root directory. On a Windows system, that's going to be the C drive and the D drive. You then work up to the next level, which will be users, and then on to your home directory. And each of these will be separated by a /. Now, on a Windows computer, that would be a \. On other systems, it's a /. Now, we have got, so I showed you above, we've got those directories. Now, we can, if we add a flag, so you can provide a simple command to the shell system like ls, and it will just carry out the default behavior for that. But you can also add to that flags. So these are usually preceded by a dash or 2 dashes if it's a longer command, and the letter for that flag. So in this case, -f is going to add indications for what those objects are. So if you've got directories, they're going to have a / after them. If you had a link, which we don't have here, you would have an @ sign. And if you had an executable, so a program, you'd have a star after it. So all we have here at the moment is directories and plain files like this. Now, you all might also see, depending on what your defaults are, that there are colors which indicate these. So on my system, directories are always colored blue, executables are colored red, I believe, and so on. Your system might have this helpful coloring, or it might not, depending on what you're working on. Now, the other command, which I'll be using a lot, is clear. What this does is just empties your terminal so that you can get rid of what you've been working on previously. It clears your head, essentially. It gets rid of that extra information. So we have this command ls, we add the flag for one last option or one last object we can add to this is an argument. So we have a command, we have flags, and then we have the arguments after that. So in the case of ls, what that argument will be is where we want to look. So here we are going to look at the root directory. If you are on Windows, I think you would want this. If anybody is on Windows can confirm, that would be great. But on a Unix or on an OS X system, you'd use this. And what this will do is it will list all the items in that root directory. And so here I have got these folders. I've got an applications, I've got users, and my home directory is inside of that. We have got links to other objects here. So these are, if you're on a Unix system, these will be familiar as well, because you'll have var and etc. and user. On Windows, you're going to say different things. You'll see your programs directory, you'll see your Windows directory. So now to find out more about what options you have, we have help pages. So the first of these is --help, which isn't available for all programs, but is something which should, on the Mac, this doesn't actually give you any information, but if you are on a Linux system, that will actually tell you, give you a help page. So here, no, that just means human readable. So if you're on a Linux system, or if you're on Windows possibly as well, --help will give you a page illustrating what commands you can use. If you don't have that, as I don't, you can also use man pages. So these are manual pages. In Unix systems, each command which is part of the system should have a man page. And it would help if I put in the right command. So what I did there is you can use the up and down arrows to go through your history of what you've typed in. So if you make a mistake, you can use the up arrow to go back to the previous command where you had the mistake, and you can correct it. So that's what I've done here. I've looked for the man page for list rather than the man page for help. Now that man page will give you more information about how you can use this command, what flags you can use. So for list, there are a lot of different flags that can be used for this command. And you also have here guidance on what arguments you can pass to that command. So you can navigate through this using the up and down arrows. I would recommend at break time having a look through some of those and see what other options there are. Now, if you try and enter a command which isn't, or a flag which isn't an option, you'll get told, as we did up here, that it's an illegal option, and it will give you a bit of usage information. So it says, okay, you've made an error. These are some of the options which you can use. So you can have a look through and try and see if you can find the option that you're after. Some commands have more useful help pages than list. A lot of them will have quite a detailed breakdown. In this case, it's quite basic. Now you can, a lot of documentation for these systems has been put onto the web, so you can use Google to search for these commands and look for more information on using them. Okay, so what we're going to do now, I will clear my terminal. We're going to have a look at the desktop. So
I have a question.
oh, sorry, yes, you have a question?
Yeah, so you when we go to the manual list, man ls, how can I come back from that
Yes.
manual list back?
Sorry, yes, that is a very good question. I should have told you that. Sorry, yes. If you use Q, so you press Q from inside of that and it will quit. So for any of these programs, commands to try and get out, it will either be Q or it will be escape or absolute kind of panic. Control C will should get you out as well. But usually it will be Q or escape will leave those. Okay.
Thank you.
So,
Sorry,
thank you for reminding me.
sorry, but
So yes, Lorenzo.
I'm typing man. Is it LS or 1S?
LS, yes. 1S, so yes, man LS.
Have a look.
Does it give you a man page? It might not,
No, it's
depending
the
on which.
it says command not found.
I don't know. I think that git bash, are you using git bash?
Yep.
Yeah, I think that might not have the man pages.
Okay.
I'm not 100% familiar with git bash.
Cool.
So hopefully the ls -- help will give you information.
Okay, thanks.
If you, yes, if you're using git bash, you could use Google and Google man ls, and that should bring up archived copy of the man page. So hopefully that should help. Right, okay. So what we will do now, that is very unhelpful. Okay, so we'll move on to looking at the desktop. So I'm going to look now at the desktop. And so on the desktop, we have the zip file that we copied over earlier. And I've got this data shell directory here. So we can have a look at that data shell directory. So we're now going to look at the contents of that directory, and we see we've got these directories here, creatures and molecules and data, and we've got some plain files here, so a PDF and some notes. So to get to that directory, we can use the cd command. Now, previously we had used cd by itself and it took us to our home directory. What we're going to do now is use cd desktop, and this has now moved us to the desktop. So my prompt, it shows desktop here. And if we type in pwd, that tells us that we're in that directory. So we're now going to go into data shell. And I want to go into this directory here. So I'm going to cd data. So if I now run pwd, this shows us that we are in the data directory, within data shell, within desktop, and within my home directory. And you should all, if you could follow through that and get to that location as well. Now, if we do this, so we list what's in this space, this directory, and we've got these directories, animal counts, elements, and PDB, and some files. Now, if we wanted to go back to data shell, we might think that we could type this in, but we can't because there's no such file or directory in this location. So it's a hierarchical file system. The computer doesn't see that there is that directory there. To get back down, we have to use this special path, special directory, which means go to the directory which contains this directory. So it steps us down one level. So that now puts us into desktop data shell. So we looked before, we don't
Excuse me?
see. Yes.
Excuse me, just a question. Cannot access the desktop, no such file or directory. So what the reason?
Was it this command you were trying here?
No, I mean the first command. I mean just.
The first command.
Yeah.
So
The
is this
desktop.
to get onto the desktop?
Yeah, but there's cannot access the desktop.
I can't access the desktop. So if you if you type in ls minus capital F, do you have a desktop directory?
It must be capital.
The F should be a capital, yes. So a lot of the commands in Bash are case sensitive. So make sure to follow the case when you type in.
Same things. Cannot access.
So it shows. So if you list now, is your desktop, is it a capital D or a lowercase d to start with?
Lowercase.
Lowercase. So if you, rather than typing in the capital D, can you try ls minus f lowercase d desktop?
Oh, try.
I can let Salim share his screen as well if that's going to be helpful.
Yeah.
So I'll make Salim a co-host.
But the same thing. I tried
Okay.
all options.
Right. If I stop sharing, would you like
Yeah.
to share your screen and we'll
Yeah.
check that for you?
Try to share. My
Okay.
screen.
So this is helpful because obviously I'm very familiar with this system, so I don't always see these errors. Right. So could you type in P, first just ls and press enter. Okay, so we are on, could you type in pwd, please?
PWD.
Okay, so C users and your username, and then desktop. Where would desktop be? Can you scroll up slightly or scroll up slightly?
Is it?
Okay. So
It does
shows
seem
you-
that there is no desktop.
That's
It's very strange.
bizarre. Okay, so you have
Maybe have a look in the
got-
file explorer. That might.
maybe in my documents, if you ls my documents, now you'll have to put quotation marks each side of my,
So I have to write my document or guest document.
ls and then space, speech mark, and then my
one?
document, no, so a comma.
Oh, okay.
The quote.
Oh, okay.
Sorry, quote, yeah. My document, so it's capital M, Y.
Sorry, Doug, Jonathan's made a valid point, and this is the same for myself, is that some of you out there who are using OneDrive, your desktop will be moved to your OneDrive. So as a contingency, you might want to think about a more simplistic file path for everyone to use.
Right, okay, so if you looked, so don't look in my documents. If you ls OneDrive.
So I have to type ls OneDrive?
Yes, so if you, and it needs to be a capital O. So first off, just type a capital O. Now press, wait, delete, press tab.
Tab, okay.
Tab.
Yeah.
Okay, this is a quick tip for everybody. To save errors when you're typing out paths, use autocomplete, which is the tab button. So you start off typing what you want to type, press tab. If it has one unique solution, it will find that solution for you. And that is a very useful thing. And thank you for pointing out OneDrive. So press enter now. And that, so that is in desktop, right? So it's downloading from OneDrive. So if you press the up button to get that command again, so press up button, and that will retrieve the command that you've just used. The up arrow, sorry.
The little arrow key, the up arrow key.
Yes. Okay, and then you can start typing in desktop. So D-E,
Capital must be
capital D. Yeah, so you need to make sure you get the case. Press tab to
case
complete.
sensitive.
Yeah, it's case sensitive. And press enter.
enter now.
Yes, press enter now. And so that shows us, right, okay,
Yeah.
that's good.
And this is it.
So, okay, if you have OneDrive and you're on Windows and it's moved your desktop to OneDrive, so is it easier for us to move everything, or should I just ask for everybody, if you're on Windows and you're using OneDrive, when I say desktop, can you put in OneDrive desktop? And if we could make a note in the shared notes that this is what we would do. Does that make sense, Matthew? I think that might be easier than moving everything.
I think so. I think, yeah, on the desktop, at least we know where it is. This will, if anyone else has been caught out by this as well,
Yes.
or actually maybe you're ahead of the game, you're already there, then yes, everyone, we're talking about desktop. I think that's maybe a good place for it to go.
I think that would be good. Yes. Okay. So that's good. I hadn't realized that this change was made for OneDrive. We'll have to make note of that for future lessons. Thank you. Okay. Do you want to stop sharing your desktop?
Yeah, sure.
And I'll continue on with this lesson. So yes, right. I shall share my terminal again. Okay, so, right, I will go over that again. So CD will take us to our home directory. We can use then CD desktop or CD OneDrive desktop. Now, as I was saying before, tab will autocomplete. So I pressed tab twice at this point, and it showed me that I don't have a single solution to go from D. I have different options. So I can now see that I've got desktop, documents, downloads, Dropbox. I want to add an E. I press tab again, and it puts me onto desktop. So one of the things for the terminal is try to make sure always to reduce as much typing as you can so that you reduce your chances for errors. So what we'll do here is we'll type in desktop, or we'll type in OneDrive desktop, and then we're going to go to data shell. This here shows that we have two options, but I'm going to select the directory, and then we're going to go to data. Now, as I was saying before, we can't simply use this command because we don't have a directory in this location called dataset shell. So to go to the directory above that, we need to use cd ... And that moves us down one level. So that now, that cd ... that has moved us into data shell. If we use these commands. So we can have multiple flags that we pass to a command, as many as it will take as are sensible. Sometimes different flags will conflict, but in this case, these two don't. So this is going to give us file information, and it's going to list all the files which are there. So in this case, it isn't just that we have got creatures and data and molecules. We also have here a dot file directory and a dot directory. I also have here a hidden file. So any file which starts with a dot to the bash shell, or to ZSH as well, will be hidden. So generally you don't see those. Those are usually used for system configuration. This one, I think, is a bit of a rogue file. I'm not quite sure why that's there. But so what we did here was we used this special directory, which takes us to the directory, the parent directory, for one above where we are now. So there's other hidden files. Now, all systems, all programs which work in the bash system, in a shell system, follow this path. They understand these commands, the dot and the directories. So every program that you run should be able to follow these paths. So you can use these to, when you're running programs, you can pass them information about where files are. They will follow this path, so they will understand how to find those files. Right, and then what we will do now, I'll just show you a couple more shortcuts. So when I was in my home directory, you will have seen that my prompt showed the directory as being a tilde symbol, which is this symbol here. That can also be used as a path.
Excuse me.
And that gives you a path that takes you to your home directory, like this.
Sorry for interrupting again. Your last two line, we can't see your last two line because it's go under the zoom. There is a bar at the bottom.
Ah, right. Good point. Okay, I will clear that. And I will say, right, I will show you. So we used the tilde command, which I will show you in a second. I will try and remember to clear my screen when I get to the bottom of the screen so that that doesn't happen again. So the other command we can use is a dash. And what this means is go back to the previous directory we're at. So bash has a history system and it records your commands, but it also records where you previously were. So in this case, I was in the data shell. So if I do cd dash, that takes me back to the data shell. If I use it again, that takes me to home. And again, it takes me back to the data shell. So you can, if you're working in two directories and you're wanting to do operations just in two directories or so, you can quickly swap between those. And you can then also use the up arrow to get to multiple commands. So you have a history there, which we will talk about in a bit. Now, what I'm going to do is I am going to put a quick, right. So the other way that you can do this, so you can use, as I was saying, you can combine these and you can give them to a program to use to open another file. So in this case, I'm combining the tilde mark, which means go to my home directory, and I'm then giving a path from that home directory to this file here. And I'm going to copy these questions into the shared documentation. So this is going to be at the bottom of the bash section. And it's going to be a quick quiz for you. So if you could open the shared documentation, there's a multiple choice question. Starting from users Amanda data, which of the following commands can Amanda use to navigate to her home directory, which is users Amanda? And please, could you have a look at those options? There are multiple correct options, and just put a cross next to the option you think is the options that you think are correct. And then once, we'll give you 5 minutes or so, and then once you've done that, I will go through those options quickly and just explain which are the correct options or not. So we'll give you a couple of minutes to do that. While we're doing that, if anybody has any other questions, please let me know.
It's actually on that note, Doug, that's your 10-minute till break.
Great, thank you. Okay. Okay. So okay. Are people ready for me to go through the answers, or would you like a little bit longer? If you'd like a little bit longer, put a cross up. If you'd like me to go through the answers, put up a tick or a thumbs up. I think. Okay, so going through the questions, I think we're generally there. So the first option, CD dot, which I didn't explain what CD dot was, but well, I will do that now. So cd ... which is the correct answer at the end of the page, that takes us down one level. So I was in data and I now go to home. cd ... just takes us to where we are. So the dot directory is your current working directory. That is useful for other commands sometimes if you need to pass a directory path to a program, but you just want to be working in the directory at the moment, then you can put a dot and a dash, and that will inform the program that you're working in this directory here. Now, cd dash will take you to the root for the system. Nobody selected that. cd dash home Amanda isn't going to work because Amanda is working on OS X, and so she's in users rather than home. cd ... /... will take you too far down, so that will take you into your users directory. Now cd ... will work because that takes you directly to your home directory. Same for cd. Those are both commands which take you directly to your home directory. And also cd ... as we said, that gives us this location. Now, we're in users home data. A couple of you has selected this command. If I can type, that is correct. So this is also correct, because what we're doing here is we're saying, I want to start from my home directory and I want to go into data and I want to go back out of data. So this does work. It's a very strange command to use. We wouldn't use it in everyday language. If you were talking about giving people directions to go to a location, you wouldn't say, go down that street, come back up this street, and then go left. You'd say, just go left. But sometimes if you're writing a program which takes different paths and it combines them to create one last path that the program will use, you might end up with a system like this where you say, okay, I want to find the home directory, I want to find this data directory or this data directory, I don't know where it is, but it ends up being in home. And I know that I then want to go from that data directory to go to a desktop directory, which I know is next to it. I'm not quite sure where it is, but I will allow the program to accept a path to the data directory, and then I'm going to append to that a path to desktop. You can do that. It's messy, but the computer doesn't care. It will just know this is where I'm going. So you can build those up and create paths like that. So I'm going to stop, I think, slightly early, because what we will move on to next is looking at working with files and directories. So I will, if we start the break just slightly early and come back just slightly, well, at past. So make sure that you're back at 4:30. Get yourself a coffee. And after the break, we will start talking. We will talk about working with files and directories. I will, just before the break, if there's any questions about what we've done so far, please ask now. Or if you want, if there's any details which you'd like me to go over again.
Just a quick question. I think we were supposed to have someone joining late. David, Hera or Hara. I don't know if David's joined us. I can't see him in the participant list. But if David is here and if he needs help with catching up, we can do that over the break.
Okay.
No, looks like David's not here.
Okay, so I guess if there aren't any questions, then we should have a break, reconvene at past.
In the meantime, if everyone could do me a massive favor, just to make it easier for myself and the other helpers to kind of get straight to your problems, if you could go to the Etherpad, which I have just put another link for again in the chat, so you don't even need to look for it, and then next to your little name in the attendance list, could you just tell us which operating system you're using? So Windows for Windows, Mac OS for Mac OS, Linux for Linux, and that will just like get straight to the point. So we know, like, I can look up your name and go like, cool, you're using Windows. I don't even need to ask you that question anymore. We can just get straight to it. That would be lovely.
Yeah, cool.
Even in
Right,
Zoom, we can you can rename yourselves and add your operating system in brackets. That would be even quicker way for us.
But no, that's
Whatever
right.
works for people. Anyway.
Yeah. Okay, I'm going to get myself some coffee, I think. So yes, we will. So we'll reconvene in 15 minutes. Okay. Okay, if you're back, could you put a thumbs up or a tick in the participant list or reactions so that I know that I can start again? Seems reasonably good numbers. Okay, so let's start. I'll start off gently and then we'll carry on. So I will, just before I start on working with files and directories, I will say one thing I spoke about earlier. So this command here, this relative path, or other, no, so this is So I'm going to talk about absolute and relative paths. I've selected a choice which kind of falls in between the two. So I won't talk about that choice here. I will, during the rest of the course, at times I'll talk about a relative path or an absolute path. The relative path is the path from where we are now. And that would be something like data shell data. So that is a relative path to get to this location. Or we can use the absolute path, and this starts from the root of your file system and carries on up. So if we wanted to go to our home directory, for example, we could use either the relative path of going down a couple of levels, or use the absolute path, which goes from the root up. Both of these are valid paths, as we showed in the example at the end of the last session, that there's multiple ways to get to the same location. Depending on what the situation is, these will be more or less useful. So sometimes using a relative path for a command can be useful if you're wanting to work on directories you know their location relative to where you are. If you are wanting to work on directories from wherever you are, you don't care about your current location, but all you care about is where those directories are, then using an absolute path can be more sensible. Now, what we will do now, so we are going to, I'm going to go to the home directory, and we're going to go into the data shell directory. So this will be desktop, or it will be OneDrive desktop data shell. So currently we are here, and we have got these directories. We've got creatures, data, molecules, and writing, and North Pacific Jai. Now, if we wanted to create a directory for writing a thesis, or if we are wanting to start some writing on a thesis, it isn't, say in writing you might be doing papers, but you want a specific space for working on your thesis. So inside of desktop data shell, what we're going to do is create a directory for doing this. Now on a GUI, you would go to that directory and select create directory. In the shell interface, you use the command mkdir. This is make directory. And you give it the name of the directory that you wish to create. Now, if we list what's there, we can now see that we have got this directory here, thesis. So if we look inside of thesis, we see that there is nothing there yet. It's an empty directory. So theses are obviously quite large documents, so we might want to organize, rather than have a single directory in which we are putting everything, we want to have subdirectories in there. So perhaps we would want to say, we want to make a directory thesis, and we're going to say we're going to create a chapter 1, section 1, subsection 1. Now this command isn't going to work because it tells us that we don't have this directory available for us to create another directory inside of it. So we need to add to this command the flag -p, which tells the bash that we want to create the path. So if we're creating the directory which has parent directories which don't exist, we're going to create those at the same time. Now, Control A will take the cursor to the start of the line. This is a very useful shortcut if you've typed in a very long command and you realize that you need to make a change at the start of that command, Control A takes you to the start. Control E takes you to the end of that line. So we're going to use Control A to get to the start of that. So I used the up arrow to retrieve that command that I typed in already. Control A to go to the start, and then a -P. And this will create the path to this directory. So now we're going to check that that path has been created. So we're going to list, giving the full information. We're also going to use a recursive listing. So for capital R, recursive operations are quite common to shell operations. A lot of times it will be a lowercase r to indicate recursive. In this case, it's capital R. And this means that we're going to list the contents of every directory below thesis. So inside of thesis, we have chapter 1. Inside of thesis chapter 1, we have section 1. And inside of thesis chapter 1, section 1, we have subsection 1. And that last directory doesn't have anything in it. So I will clear that. I'll list that again just to make sure that it's readable. So you can see what is in each of those directories within the thesis directory. Now, good names for files and directories. So the first advice is try not to use spaces in a file name or a directory name, because Bash, the shell system, uses spaces to control how a command is typed in. So if you have, for example, list -f, that comes up with command not found. That's because we need a space here. And similarly, we need a space there. Now, if we have a file name or if we have a folder name which have a space in them, we aren't going to be able to simply list what is there. You would have to actually put that folder or file name into quotation marks so that the shell system knows that it's looking at a single object. So shell system works on strings, and it will take each of those strings, it will break based on spacing. So if you have anything which has any file name or folder name which has a space in it, you need to have quotation marks around that so that the shell knows not to break it up by the space inside that. That is a pain to type in, so I recommend just not having spaces in your file names. Also, don't start a file name with a dash, because that will you'll end up with the system thinking that you're passing it a flag when you're not. Inside your file name, the best thing to use is letters, numbers, underscores. You can have a dash in there if it's not the first character, and you can also have dots. But try to avoid any other symbols in your file names. You will get them. There will be times when they are there, but try to avoid that. If you have any file names which have spaces, have special characters, anything like that, you can use quotation marks around them in order to avoid those causing problems with your program. So inside of thesis, so we're going to cd to thesis, and we're going to create a text file. And we're going to create this text file using the Nano program. Nano is a text editor. Now, this is different to using, say, Word or Pages on the Mac, because this is a plain text editor. It doesn't add any formatting to the text that you're going to create. So if you type in nano draft.txt, this is a text editor which is in your terminal. So it doesn't have a graphical interface, it just sits there in the terminal. It will tell you options down here, give you some advice on what controls you have. Anything which is up hat and a letter is a control and that. So control X is to exit in this case. So what we're going to do now is we're going to add in some text so you can type this in as you would type in standard text editor that you're used to.
But yeah, they don't change. They don't change the date of them.
So you can use the arrow keys to navigate. You can't click, so I can't click onto here. Well, I can click onto there and drag and drop because the Mac system allows me to do that. But what I can't do is click somewhere to move the cursor. I have to use the arrow keys to move the cursor around this document. And then to save that, Control and X will exit, and it will ask you, do you want to save this document? Type yes, type Y rather, and that will answer yes. And then the file name that we want to write is draft.txt, so we're going to use that same file name. And so we have here that program has created. Now, if we list, we have got the chapter 1 directory and we have a draft.txt. So another way to create a file is you could use the touch command. And that will also create a file. But if we look at these two files, so list -L for long, so this will show file details, and H for human readable, because sometimes files, you don't want to see the size in bytes, you want to see it in a human readable format. So here we have got the draft text file, and that has got a size of 64 bytes. And this file that we created with the touch command is at 0 bytes. So it's been added to the system, but it has no information in that object at the moment. Now, we are going to change back, CD back to the data shell. So we want to be in desktop data shell or OneDrive desktop data shell. Now we want to move that draft. What if we decide that we don't want draft to be draft, we want to make it a more usable name, and we're going to call it quotes because it is a quote. So we're going to rename the file. The way that we're going to do this is we're going to use the move command. So this moves so we're going to move thesis draft. So we're giving a relative path to that file. And then we're going to move it to thesis quotes.txt. I should say that these file extensions are purely for our convenience, so that we know it's a text file, or we know that it would be an MPEG file or a MP3 file. The operating system, Unix operating system, doesn't care about those file extensions. You could call it anything and it will just go, it's an object. And it will trust you if you say, process this as a text file, it will process it as a text file, even if it isn't. So you will need to make sure that you pass, when you pass files to programs, you know what you're passing. So we have moved that command. We have no information back, so we know that that has been moved. So if we look at, if I look now at thesis, rather than having drafts.txt and my file.txt, we've got quotes and my file.txt. So that's the first use of the move command, is that we can rename files using it. It's a very useful command. The second use here is that we can move files within the file system. So in this case, we're going to move quotes down into our directory. Here we are, that we are now. So this is one of the first uses of the dot directory. So this means I want to copy the quotes directory into the directory I'm in now. And if we then list, we see that it is here. Now, we didn't need to say, I want to move to quotes.txt, because we're not renaming the file, and the operating system will go, well, if that last argument is going to be is a directory, I'm not going to rename what I'm moving, I'm just going to move it to that directory. So now you might not always want to so yes, so now what we're going to look at is copying. So you might not always want to just move a single copy of that file. You might want to create extra copies. So if we want to copy a file, we use the cp command. This copies. Now we're going to copy that back in to thesis, and we're going to rename it, when we copy it, to quotations. So this is creating a copy of that file, but it's going to have a new name. And so now if we use list, now the list command, you can say, just list this location. You can ask it to list multiple locations. So you can have the copy command, the move command, they use at least 2 arguments, which is the original file or directory and where it's going to. List can have multiple arguments as well, and it will list each of those arguments that you pass it. So if we were to say list this directory and list thesis quotations, you get thesis quotations here, and you also get the contents of our current directory. So you can pass multiple arguments to these commands. So now we are going to copy the directory. So we want to copy thesis to thesis backup, because it's always good to have backups. The last lessons this week are going to be teaching you about using Git, which is a much better system for backups. But at the moment, we don't have that. So we're going to just copy that directory and call it thesis.backup. Now, because thesis is a directory, the copy command is set up so that you don't copy directories by default. So if you want to copy what's inside of that directory, because it would take the directory and it would take everything inside of there. So if you want to copy everything, you need to use the recursive flag. Now, for the previous, the ls command, recursive is a capital R. For copy, recursive is a lowercase r. Unfortunately, in Bash, there is a lot of reuse of different commands and flags, and sometimes there is not a lot of consistency in the way that these flags work between different commands. So you're going to have to remember for a specific command what that flag is. If you need to check what options you can use for a command, remember that you can check the man page, which will be available via Google, or if you're on a Linux system, on Mac system, you can check that directly on the system. So what we're going to do now is copy recursively. And now, if we list thesis and thesis backup, we see that we have got the same objects in each. So we've got chapter 1, we've got my files and quotations. Okay. So what we're going to look at now is removing files. Yes, so one of the options that we do have, so I'm going to show you, if we go into thesis backup, I'm going to clear. So we're in thesis backup. I want to move quotations, but I want to do this interactively, and I'm going to move it to my file. So the -i interactive option allows you to control. So if you are doing an action like a move action or a copy action, also has -i, and the next command I show you, which is remove, also uses -i for interactive. Very important for the remove command, because there is no waste bin when you remove files on the on the command line. Once you remove them, they're gone. So the -i flag is interactive. So in this case, it asks us, do we want to overwrite myfile.txt? We don't. This is our backup, so we don't want to. So what we can do is we can enter n for no, and we won't move it. So that interactive flag works in the same way for move, it works in the same way for copy and remove, which I'm going to show you now. So we are in data shell, and we have got this quotes file here, which we have copied into thesis again, and its quotations. So we don't need this copy. So we're going to delete it. So we're going to delete it, and I'm going to show you that we should use -i for interactive, because if you don't use interactive, it will just delete it straight off and you get no options. So that's okay if we're specifying a single file and we know definitely what we're deleting. But sometimes if you're specifying multiple files, you might accidentally specify a file you didn't mean to specify. So interactive is very useful. So in this case, we're going to say, yes, we want to remove quotes, press Y. And now if I try to list quotes, it's going to tell me that there's no such file or directory. Now, we can remove directories. However, the remove command, like the copy command, is not set up to remove directory automatically. If you want to remove directory and all its contents, you need to do that using the recursive flag -r. And we're going to, I'm not going to use the interactive command here, but you should, well, actually, I will show you what it does. You need to be very careful when you do a recursive removal, because that gets rid of everything. If you haven't checked what's in there, it will just delete everything. So in this case, we want to examine the files in directory thesis, yes. We want to examine files in directory chapter 1, section 1, yes, and subsection 1. So it goes to that root up to the highest level, and then it just goes, okay, there's nothing there to delete, so do you want to delete this directory? Yes. Do you want to delete the next directory, and so on? If you press no at any point, and then you try and delete something else, it will tell you that that's not empty, you can't delete it. So you can, if you wish, go through. So that right at the end said, the directory is not empty, we can't remove thesis, because because we still have directories in there. So we still have inside of thesis, chapter 1, section 1. And so yeah. So that's how you safely remove. Now, if you're removing hundreds of files, you don't always want to do that interactively. So in this case, you could just do -r, and then thesis no longer exists. Okay, so what we're going to do is make another backup now. So we have got here, we have got amino acid. Where are we going? Yes, sorry. So we're in data shell. We want to go into data. So we're going into this directory. So that is going to be our location. So we're in desktop, data shell, data. So inside of here, we have got some files, amino acids, animals, morse, planets. We've got some directories as well. We're going to make a backup of some files. So we're going to make a directory backup. So before we do any processing of these files, we're going to back them up to make sure that if we change them in any way, we have a copy. Now we're going to move them. So we could copy these individually. So we put the file and we put the location that we're copying to. But we can also specify more than one. So in this case, we're going to copy amino acids and animals.txt, and we're going to copy them into backup. So copy command will assume that every argument you pass it until the last one is a file or a directory to be moved, and the last argument is going to be where you move to. So now we have got those in backup. Now, if that last argument is a file, you're going to get an error. Because if you are moving more than two objects, files, or directories, this last argument must be a directory. And if it isn't, the copy command is going to tell you, sorry, we can't do that. Now, you can also use wildcards. So what we are going to do, what I will do here now is show you some wildcards. So rather than say, I want to copy amino acids and animals and morse and everything, what we can do is say, I want to copy any file which ends in .txt. Now this star here, it's a wildcard, and that will match any character any number of times. So if we do use ls_star.txt, it will list all the files which end in txt there. So we can use that to copy star.txt to backup. And now if we look at backup, we see that we have those files and we still have them here. Now, the other thing that we have, as well as a star, is that you also have a question mark. So we can, if we list this, that matches that, but it's not going to match. So we don't have any file directory. The question mark matches a single character, and whereas the star will match multiple characters. So what I will do now, if we see, so we want to go to, I'd like you to go into data shell. So desktop data shell and go into molecules. And so we're going to be in desktop data shell molecules. And here we've got these files. So these are molecular information files for each of these, cubane, ethane, methane. What I'm going to do is put a little quiz into the notes. So I'm going to put this little quiz into the notes. The next question. So if you could open the notes. I'd like you to take a little time to think about how to use wildcards. So we're in the molecules directory, and we want a list command which will list the ethane and the methane files only. So there's 4 options. Can you put the star next to the option which is correct? And there is just one correct option this time. So have a look at those 4 options and put a mark next to which one you think is correct.
Hey, sorry to maybe ask
Yes.
such a dumb question. I missed it the first time round, but how do we access these questions? Are they getting fed back to you, the answers online, or I just don't see it in my what I've downloaded so far.
So those questions, so I'm putting them into the shared document. Now the questions that I'm giving you, I've copied directly from the course material. So we're currently in lesson 3, and there is, in that material, there's the material that I've been teaching you, and also there's a few challenges. Now I was going to say, which I forgot to say, I'm not giving you all of the questions and all of those challenges that's in the material, because this course is set up for about 4.5 hours work, and we have 3 hours, so I'm not covering everything. So if you want to see these questions and see some more of the explanations of those, have a look in the course material after this morning, and there will be the questions that I gave you. There's also going to be a lot more questions covering other aspects, and I would recommend having a look through those questions and seeing, just going through them and make sure that you test yourself and make sure that you've picked up on all the information I've been trying to teach. Does that make sense?
Yeah, cheers. Thank you very much.
Okay, great. Any other questions? No. Okay, if people are ready to carry on, I will go through the answers. I see we have 2 candidates for potential answers. So the first one is list star aim.pdb. So in this case, we actually get 4, because this T star A, so we're matching here. So it actually matches here. Sorry, what I should have said, and I forget sometimes because these wildcards are slightly different for different systems or for different users. In this case, the star is 0 or more. So this T aim actually matches here, because this star matches no value. So yes, that is an error in my explanation from earlier. So I should have said that the star matches 0 or more times rather than 1 or more time. So the correct answer is answer number 3, which is this. So it's specifically saying we want 2 characters here. So this is match a single time. And that will mean that we're going to not match stuff, names like this. So that's the reason why that is. I made a slight error in my explanation earlier, which was probably misleading. So a star matches 0 or more times, whereas the question marks match exactly 1 time. So there are, as I said just now, there's a lot more questions, challenges in the course material. So I recommend this afternoon, if you aren't already all bashed out, have a look at those and go through those to check that you understand how this system works. Okay, so what we'll move on to now. So far we've been talking about using a single command and doing a single action. Now what we're going to look at is how to pipe information from one command in the bash system to another command. And this is where you start to see the benefit of working at a command line interface, because a lot of what we've been doing already, you could do on a graphical interface. You could select multiple files, drag them, drop them. These are not difficult operations in a graphical interface. Now we're going to show you some of the extra operability of a command line interface that you can pipe that information from command to command. So we are in desktop data shell molecules. We're going to go into data shell. Actually, sorry, we're going to stay where we are. So we want to stay in data shell molecules. And inside of here, we have these 6 files. Now, I'm going to show you one of the commands included in bash, which is word count, WC. And this will give us this information here. So the first bit of information is the number of lines, I believe. Then we have the number of words, and then the number of characters within that file. Now we can get that information for every file. If we use word count star.pdb, we have that information for every one of these. So that's quite useful if you want to quickly see what is in your set of files, what you have here. There will be commands that you could use. These examples that I show here are all working with text files, but you will have programs which can work on sound files, which will give you similar bits of information, and they will be presented to you in a text format, that information once the file's been interrogated, and you can then process that text information in the same way as I'm demonstrating here. Now, if we wanted to just look at the number of lines, we can use the -L flag. So for list, this means list a long information, but in this here, it means list the lines. So that just gives you the line count for each file. If we wanted the number of characters, we could use -M, and so on. Now, this is one of those things. We can, with list, just list everything here. If we use a command and we say want to get the word count for each of those files, we might think that we can just say word count -L. This then sits and it waits for you to give it information, because at this point, the command, because it's not been given an argument to say this is what I want you to work on, it expects that you're going to pipe it information from the inputs, and you're going to pass it information that it should then work on, and it will just sit there and wait. You won't get any warning about that. So sometimes if you have something sat here like this and it's just waiting, and you realize you've mistyped, you can you can cancel that using Control-C. So that's a very important command to remember working on the command line. If you've started doing something and you realize you've made an error, you want to stop that process, Control-C will cancel it. Now, this is a more common error than you might think. We recently, for my day job, we've been building Conda packages for the GROMAX program, and we built our build system which had a command which was waiting for some information. We forgot to pass it any information, and that build system just timed out after 5 hours, and that was our limit to how long we could use to build the system, and it just timed out because it won't tell you. Bash, it will assume that you know what you're doing. So if you make a mistake, often it won't tell you that there's a mistake. It just assumes you know what you're doing, and it will wait for you to carry out the next process. So be aware that it is possible that you'll have, if you don't get it quite right, something odd will happen, and you can cancel that with Control-C. So what we're going to do now, so we have shown that you can get the line counts. Now, this is informative, but if we want to use it for other operations, we need to store that information somewhere. We don't just want it printed to the screen. So we can pipe that information to a file. So we can use this arrow, which means that we're going to redirect this information rather than printing it out to the screen. So we have this plain text printout here. We're going to redirect this printout, and we're going to put it into this file. So now we have got a file here, lengths.txt, and we can check what's in there using the cat command. So this cat command will just print out what's in that file. So this is exactly the same as we saw up here, but it's now in a format that we can take that information and use it somewhere else. So I will say, so we have used cat here, and I'll stick to just the cat command because it's simpler. You can also use the less, which gives you the same output as I showed earlier. So less will give you all that information and allow you to navigate through large files. Q to quit that. We're not going to use that for these lessons. I'm going to use cat, but just be aware that if you're dealing with very long files and you want a more manageable way of processing those, you can use less. So inside of lengths, we have these. Now, what if we want to sort those? We can sort them. We can sort those files like this. Now, if we want to use now, there is an option here, sort -n, and there is sort. Now, if you're running sort on a Linux computer, or if you're doing this on a Windows computer, could you tell me, do you get, from the sort command, do you get this output? Is it exactly the same, or is it a different order? I think it should be the same, actually. Same, yes. So this is because we have very handily spaces. And these spaces, a space comes before a 1, and a space becomes before a 1. So that does. Right. I'm going to just create another file now. test.txt. So I'm going to create a file with these numbers. So if you could nano length _test.txt, put in these numbers, any numbers, like this. And we're going to save that file. And we're going to save it as length.test, underscore test.txt. So that was Control-X to exit, yes to save it there. So we have got length test. Now, if I sort length test, we would hope that it would be 2, 6, 10, 19, 22, but it's not. The basic sort command sorts based on alphanumeric, not numeric. If you want to sort by numeric, you have to use the -n flag. Now, the reason why it looked the same here is because there's the extra spaces. You have this very helpful formatting in the output from the word count command, which has added these spaces, which makes it look like you're doing a numerical sort, but you're not. The basic sort is actually alphanumeric. Now, once we have sorted those.
Please clear the window.
Sorry, say that again. Okay, no worries. Okay, so if we are running sort, so we're running sort -n, even though we know it's not, using -n isn't needed, we can save that again to another file. So sorted lengths.txt. So we got the word count, the number of lines. We've sorted based on the number of lines, and now we're saving that again to another text file. So sorted lengths, that now has this information again. Now we can, if we just want that first bit of information, we can use the head command, -n. So this -n here says, I want this number of lines from that file. So head -n1 is, I'm going to take the first line of this text file. There is the reverse command, which is tail, and that takes the last line. So if we wanted to look at more, we could say 1, or we could say 5, we could say 10, 100, and so on. Now, a word of warning is that you don't want to pass information. You don't want to pipe information. If you're sorting a file, if you're getting information from a file, sorting it and passing that information back into file, this is dangerous. Now, I don't think it matters massively in this instance, but there are other programs which will operate on a file. They'll keep their access to the file open, and they'll operate in steps through that file and then pass the information out as they go along. If you start writing to that file that you're opening to operate on, bad things could happen. You could end up with a sorted file which is not what you were expecting. You might remove data before you've saved it. So I recommend not doing this. If you're going to do something like this, you would move it to sorted lengths.txt, and then you copy that back. You would move that back or copy it back to that. So we would interactively, and we say, yes, we want to overwrite that lengths file. Or we could say, yes, we would overwrite it. I'm going to say no in this case. But yeah, so if you're operating on an object, don't pipe information back to that object. Now, we have got the pipe command, or sorry, this arrow, which will redirect command. We can also redirect onto the end of the file. So we have an echo command, which I will demonstrate using echo. Echo is very useful because all it does is just repeat the text string after it. So it treats everything after that as a text string, which is very helpful for debugging because you can check what a command will actually be. So we're going to use it in this case as another way of creating a test file or creating a file. So we're going to say echo hello into redirect that output to test file. So we're going to cat test file. Now, if we want to add again, so if we were doing this, so we do echo world to test file, what we now have is world, because that will replace all information in the file that you're piping to. Now, if you don't want to do that, so we'll go back again. So I'm using the up arrows to get those previous commands. So now we have this. If we want to append information, what we, instead of using a single arrow, we can use two arrows, and that appends this information to the file. So this is very useful if you have multiple commands that you're going to carry out. You want to build up a log file, or you want to add extra information to a standard file. You can start appending that information. Okay. Now, so far we've shown you that we can pipe that information that we've generated from a command into a file. But if we want to redirect this to another command, we can, rather than redirecting to a file, we can use the pipe symbol. So we are in molecules. We've got these PDB files. I'm going to remove all the text files just to keep my workspace clean. So what I'm going to do now, so I'm going to take a word count, a number of lines of these files. So that just outputs in the shell. We then showed you that you can pipe that, or you can redirect that information to a file. Now what we're going to do is pipe the information. So this is using, usually this symbol is, this pipe symbol is going to be next to the enter key. So it's usually above the backslash on a Mac keyboard. Sometimes I think it's by the lower left shift key on a Windows keyboard. But this is the pipe command, and this will pipe information from one command to another command. So in this case, we're going to take that word count and we're going to sort it directly. So that, rather than having to put it into a file and then work on that file, we're directly working on this information now. And then you can carry on this system. You don't have to stop at one pipe, you can pipe again. So we're just going to take that top line. And so we have got 9 methane. So you can build up this pipeline. You don't just have to pass that to direct to a file. You can, at the end, if you wish, pass that information out, save it as a text file, and now we have this file, shortest file, and that is that information. So these commands, you can, on the bash shell, you can build up multiple commands. You can build these pipelines of operation. Now, because you can pass information from command to command, you tend to have small commands which do one task but very well. Jonathan, you have a question.
Oh, well, maybe you're about to answer it, actually. I was just going to ask what happens when you have commands that have multiple input parameters. How do you know which one it's piping into?
That is a very good question. I'm not going to answer that right now, but we will cover that. Because yes, there is definitely, if you have multiple inputs, you can't always pipe all that information. Now, if you pipe it all together, it might not be operated on as you expect. After the break, this is lovely, I can preview what we're going to do. We're going to talk about looping and carrying out loops where we operate the same command on different objects, on multiple objects one at a time. And that would allow you to do this operation where you make sure that you are just getting the exact right information for each file you're working on. So after the break, your question will be answered.
Thank you.
Cool. So yes, so that is, this is piping. There are questions in there about how to deal with pipes. There is an instruction, there's some information there. So I'm going to data shell. I will just preview. So inside, this is in data shell data, we have got a file which is animals. And we can break up this file. So we have the cut command, which is going to use a delimiter, -d is delimiter, which we're going to use comma. And we're going to take the second field of animals.text. Now that can, and that can then give you that second field. Now, there will be questions, there's some examples to go through using the cut command and also using the unique command, which cuts down and just, I think, should focus, doesn't actually, in that case. But there are some questions about how to use those. I will leave that for the end. The other thing I'm going to do is just very quickly in data shell, so clear, before we have a break in a minute's time. So we are in data shell, and I'm going to show you North Pacific Gyre. So this is a set of data inside of this directory. So we have these files here. Now these are text files, but they have a very systematic machine readable naming system. Now what we want to do is to highlight those files which just end in an A and a B. And this can be done. So you can go a.txt and you can use b.txt. You can also, I will just show this now to you. This is a little teaser for regular expressions. You can also specify that you want to match either A or B using the square brackets. And these, what this will do is that you will match one of those characters. So you wouldn't match both of them. If it was an AB, you'd just match the last of the characters. But that then matches all of those. So that is another option as well. You've got the question mark, which is a single wildcard character. You've got the star, which matches 0 or more characters. You've got the square bracket and A or B, or you can put in one of the characters you want to match, and that will select one of those. So there are, within the system, there's powerful ways of building up these searches that you wish to work on. But I'm not going to go much more into that now. So yes, so we'll have another 15-minute break. Is it time for a break? I think.
It is. Apologies, sorry, I missed the boat. My son was kicking off, so we were just sorting that out. But yes, we are. 15-minute break.
15-minute break. Okay, good. So yes, we'll have a 15-minute break. We'll reconvene at 11:45 when I'll start talking about loops and how we can carry out the same processes on multiple files. If you have any questions, ask them now. I will cover those, but otherwise, if you want to get a coffee or anything, go and get that now. And if there aren't any questions, I'll go and let in the cat if she's desperate to get in.
I've seen Andrew talking, but I'm not sure if he was talking.
Dash, and you can have as many of them following that dash, or you can have them separate, so it's easier for you to read. That's fine. So you could have -L, -S, or you could have -LS. It's fine. Okay. You can also have long options, which is this here, -- long option. Now that is a more human readable option. Now the basic bash commands don't usually have long options, but if you're working with a program which has more complexity, you might see that there are long options. Now, for example, if I scroll down here, this should there's a lot of options. So what you can have here, so zip has an option -O, which allows split archives to be worked on. But you could so to allow split archives to be updated and saved to a new archive, so that -O is going to be that output file, or you can use.
I think I saw what you were. Yeah.
Yes, or you can use -- or -- output.file or -- out, and that would do the same thing. So if you are writing something, if you have that option for writing something which is has a long option, you can use either the long option or short option. If you want your script to be understandable, using the long option is better, because if I'm going to talk about that a little bit more afterwards when we're looking at writing scripts, but making it human readable is very helpful. The computer doesn't care how many characters there are. We might, if we're typing and you don't have autocomplete, we might cut corners, use short options. But if you have long options, it's best to use them so that you do have that extra information when somebody else tries to use your script.
Okay.
So does that answer your question?
Yes.
It's possibly a bit more information.
No, that's really interesting, the extra information. Thanks.
Yeah, cool. I'll go and get some coffee.
Good.
Okay. I guess we're at about 11:45 now. If you're ready for me to start again, could you, am I ready to start? I'll just have a drink. Yes, if you're ready for me to start again, could you put a tick or a thumbs up in the participants list? Yeah. Okay, I will share my screen again. If I can, right, there we go. So I am going to clear that screen. So we'll continue now looking at loops. So far we've been carrying out a single operation on whatever files or directories we're passing it, and this producing a single set of outputs. Now, what if we want to perform the same action multiple times on different files? We want to get an output from each of those files. So we're going to have a look at how we can loop through commands and carry out these commands again and again. So what I'm going to do is I'm going to cd to desktop data shell, and we're going to go into the creatures directory. So navigating from a home directory, so if you're on Windows and using OneDrive, you'll need OneDrive before this, so in between the tilde mark and desktop. And we will be in this location. And the contents of this are these 3 data files, which are plain text, describing Basilisk, Minotaur, and Unicorn. Now, we can take the top of the top 5 lines of each of these. So Basilisk, Minotaur, and Unicorn. So we're just going to here output the top 5 lines just so that we get an idea of what's in each of these files. And here, the head command tells you which file it's from, and it gives you the top 5 lines. So it gives you common name, classification, and then the start here, which is presumably going to be some sort of DNA sequence. And this information we're getting for each of the files. Now that's very helpful, but if we want to do anything with that information, we should really work on each of these one at a time. So first off, I'll give you a quick illustration of what the notation is for creating a for loop. So we're saying that for a thing in a list of things, so we're going to say for a file name in a list of file names, so we're going to say Basilisk, Minotaur, and Unicorn. So we start off here. We're going to create a command which runs over multiple lines. So we're saying we're for file name in, and then we're passing it the file names we want to work with. Now, file name doesn't have to be file name, it could be anything, but which we'll show you later on. But now we press enter, and you'll see here that we've got this arrow rather than the normal prompt. This is because Bash has recognized that we're creating a for loop, so it wants us to enter the rest of the commands for that loop. So for file name in these files, do. So that shows that we're carrying out a do loop. We're going to enter the operation. Now to make this readable, I'm going to indent it with a tab. Tab doesn't work actually. So to make it readable, I'll indent, but you don't need to. Bash doesn't care if you indent or not. So head, we take the head of the file name, and we'll take the last line of those 2 lines which are returned. Now here, this $file name, so we have here a variable, and that variable is going to be equal to one of each of these each time. To reference that variable, you need to use the $symbol. And we're going to press enter. Now we could carry on putting in more lines, more operations, but we don't want to put in any more at the moment. So we're just going to say that we're done. So for file name in basilisk monitor unicorn, do this operation, done. And this is what we get out from that, is classification of these, of each of these. So that's taking the second line. If we scroll up, you see unicorn, we have common name and classification. So we're getting this second line. Now, if I use the up arrow to retrieve that command, you see here that we have the first line. Now what Bash has done is it's put all of these commands into a single line, but it's separated each command by this comma. So that indicates the end of the line. So if you have multiple commands that you wish to carry out, but they're separate to each other, you can just lump them one after another on a line like this. So we have another semicolon here and a semicolon here, which breaks up that process. And that runs in exactly the same way. So we don't need to use file name. So it doesn't matter what we call this variable. You could say for x in basilisk monitor unicorn, do the head $x. So that's referencing x, which is your variable, and get the tail. Yeah. And that does the same thing, but it uses a different variable name. So this, what you call this, doesn't matter to Bash. It doesn't care what you do, what you're using here. But if you call it folder, it will work on it because it's the same thing. But that's going to be confusing for people to read. So try to make your variable name descriptive. Try to make it so that it describes what that object is that it contains, or rather what it references, because this variable will contain the string for basilisk.
Doug, I just tried doing that with substituting ls for the file names, but it didn't like that.
Okay, so you tried to do this, that, did you?
Yeah. Mm-hmm.
Yeah. So because what's the structure that the for command expects, it expects you to pass strings to it. So it's not going to try and use that ls command to create the strings that you're passing. It expects you to have done that already, which is why it doesn't work there. There are ways for us to get around that, which I will show in the next lesson, I think. Do we show that? When do we show that? Let me check. We won't be. I'm going to try it now here. So what you can do, this is a little preview, which might work. Here we go. So what happens here is this is a special command which runs the list command before then running the rest of the commands. And so what it's done here is it's created for you that list of files before then it carries out the rest of that operation. You can pass multiple operations to that. We're not going to cover that in any more detail in this lesson. There are a lot more kind of powerful operations that you can do using these subshells. But yes, just be aware. So generally, you need to have already created that list of strings before you pass it. Now you can, if you wished, the other option you can use is star.pdb, because what will happen is this command will expand this wildcard. So in the same way that list star.pdb will expand to give you all the file names, here the for command will expand that. No, it won't expand that. I thought it would.
You don't have any PDBs in that folder, it's DATs.
That would be why, yes. I'm looking, thank you. That is very helpful. Always be aware of where you are and what you're working on, and don't copy a command directly from the example where they've just moved to a different directory. So yes, you're absolutely correct that there are no PDB files. So if we try here, now I think what this is actually doing, because the error here is head, so it's not that it's been the errors come here. So what happened here, the force command tried to expand that. It didn't find anything. So it just passed the star.pdb directly. What happened in here then is that head tried to operate on star.pdb, and there was nothing, so it didn't operate on that. Now that we did a star.dat, because there are .dat files, that gets expanded. And so the for loop then loops through each of those files and gives you, passes each file name one by one to the head command. So yeah, so sometimes if you get something slightly wrong in Bash, it will give you results which you don't quite expect. Debugging in Bash is not very easy, so it's best to be careful first time with these. So what we're going to do now is I'm going to have a look at, I'm going to put a quick question up. So this is 5. So what I'd like to ask, so this is in the data shell molecules directory again. I'm going to put this into the chat. Sorry, not into the chat, into the shared document. So it's question, what would be the output of running the following loop in the data shell molecules directory? So we're saying for file name in star C star, and then we're listing $file name. So just put a star next to which of those options you think is the correct option. There's only one correct option. And this is more checking that you're familiar with the wildcards rather than familiar with lists, sorry, with for loops. So have a quick go at that, and I will give the answer in a minute or two. Okay, so it looks like it's a fairly unanimous decision that it's option 3, so listing Cubane and Octane. And that's correct, because if we remember, the star matches 0 or more characters. So it will match Octane because it matches VO, and for tame.pdb. And it also matches Cubane because the first star will match no characters, so that will be correct. Okay. Now, we're going to move on. So, as I was saying earlier, it's difficult to debug what's happening in these loops now. If we rewrite this so this is not quite readable. I do apologize. Well, actually, yeah. So what we're doing here, we're trying again to look at the files in star.pdb. We now know that there's not any files like that in this directory. What we're going to do is we're going to echo this variable that we're passing in so that we can see what it is before when we use it. So in this case, we're seeing that this is the star.pdb. So we realize now that there is an error in what we're doing. Now this, if we then now use star.dat, we then show that this is the file that we're working on, and this is what our output is. So you can, if you're building up these loops, you can use the echo command to check what your variables are so that you make sure that you are operating with what you think you should be operating with. Now, an example here of what happens if we have spaces in names. So if we say wanted to work on some file names, and we've got a file name red dragon.dat and purple dragon, purple unicorn. And this, we're going to carry out that same now we're going to put over this, because we know that we're going to be passing a file name, a file name which has a space in it, we're going to use the speech marks, the quotation marks around that variable, so that it's passed as a single variable to the head command. And done. But we don't have any either of these. Now, if we didn't do this, so if we leave out this quotation marks there, what we have here now is that head is trying to operate on each of those. So it's passed a file name which has a space in it, so it splits that up. And it says, I can't find red, I can't find dragon.dat, I can't find purple, but I can find unicorn. So I'm going to operate on unicorn and I'm going to extract that information. So you need to be careful when you are passing information that you make sure that there's not special characters or spaces. As a precaution, it's good to use quotation marks around those variable names so that you make sure that you avoid this problem. Now, another example of how we can use loops is for backing up. So we might want to back up these files. And so we're going to say, I'm going to copy star.dat to original star.dat. So this is going to expand all these three. So we're going to end up with copy basilisk.dat, minotaur.dat, unicorn.dat. We'd like to copy them simply like this, where we say we're going to copy them to original dash basilisk. This doesn't work because this file doesn't exist already, so it can't be expanded. So if we try to do this, it's going to complain at us because we're trying to copy to a file, and also that file won't be named correctly. On different systems, you might get different errors. You might get told that this target isn't a directory. On OS X, I get told just here's the, it's not so helpful. It just tells you these are the options that you should be using. So it doesn't highlight what my error is, but the error is that this isn't a directory. So if we wanted to copy a file name, so we're going to say copy file name in star.dat. We're going to do, we're going to copy $file name original dash and it would be wise to put these in quotation marks, and we could quotation mark that. So you can, within that, have multiple operations, and then you can say done. And now if we look, we have got original basilisk, minotaur, and unicorn. Now, if we wish to say append to the back of it, and I'll show you .dat, copy file name, $file name backup. Now, in order to make sure that we recognize that this is a complete block of code, we can put curly brackets around it. And what that will do is it will make sure, it will tell the system for definite, I'm referring to a variable which is named file name. I'm not referring to a file name, to a variable name which is file name.backup. Now, that is a trivial example because you might have, I don't think that dot can be allowed used in variable names, but you might not have the dot there, in which case you could end up accidentally trying to refer to a variable which is file name.backup. But that work, so that will give you that backup. I'll show you what happens. So in this case, we'll try and refer to a variable called file, and that's going to fail because we don't have a variable called file. So that will, no, it doesn't actually fail, but what it does is it just creates a single file called name.backup. And that is another example that Bash will silently fail because it will not see that it will see that there's no information in variable file. It just quietly says, that's fine. I'm just going to copy to name.backup. So that's something to be careful of, is that Bash will very silently, and I'm going to emphasize this multiple times because it's very important, Bash will silently fail if you give it something you think should be there, but it realizes is empty. It will just leave it empty. So be very careful with your script. So we can now, I'm just going to show you, we have been looking, I've been using the up and down commands, the up and down buttons to go through the history. We can look at the history by just using the history command. And that will show you every single command that you've used. Now this is stored, in a plain text file. Star, so .bash history, that will be stored there. Now it's not until you've closed the environment, it isn't stored there. Each one is stored slightly separately, but if in your history, so this, once I close that terminal, it will be stored in that. We can refer back to this. So we can use, so we've got history. We're going to get these commands here. So I'm just going to, that's 895 to 900. I'm going to say, so we are going to use, so this is a command I don't, So if I go 900, that is the last command which was on that list. So that exclamation 900, and that runs history again. So it runs that command. You can also, you can search through history. So Control-R allows you to search, and that will pull up. So you can start typing in, and that will find the command that you've been looking for. So there's some useful tools there for consulting what you've done. Now, once you look at your history, you can then copy those scripts and you can put them into other programs, into files and use them, which I'll go into in a second. The one last thing I'm going to talk about is nesting loops. And so what we can do is we can say for species in star.dat. Actually, I'm going to cancel that. Clear. That's not going to be readable. So for species in star.dat, I'm going to do, and I'm going to echo species. And then I'm going to put another for loop in here. And I mean, these aren't going to make much sense, but so now Bash doesn't worry about the spaces here, the indenting. You could, I'm going to echo temporary. It's sensible to output that information just so we know what we're doing, and then make directory species. Sure. So I'm going to put these in curly brackets, which isn't important here, but it just helps. It's a good habit to get into when you're building file names or folder names out of variables. And we're going to say done and done. So what we're going to do here is we're going to loop through the files .star.dat, and we're going to loop through this list of strings. We'll echo both of those so we see where we are, and we're going to make a directories with those. And so that for each of these, so -all, we've echoed through, gone through those temperatures, and then original basilisk, because I didn't get rid of the originals. So this is going to create far more directories than I expected. And if we now list, we see what we have here is a set of directories for each of these. So you can nest loops within loops within loops and carry on as often as you need to. So if you have a complex workflow where you're working on a range of different objects, you can build up these lists and work across, work on multiple objects. Now, we're going to move on from loops and talk about shell scripts. So I'll give you in the last 30 minutes an introduction to shell scripts. So it's very helpful having all these commands that you can look at in the history and bits, but if you want to give somebody a workflow that you've built, you need to have that in a script that they can run on their own system. So you want to be able to save this workflow as a file that you can then pass on. And fortunately, Shell allows you to do that. So before I move on, does anybody have any questions about looping? And then I'll move on to shell scripts. We'll have more time for questions later if there are any more. Okay, I'll move on to shell scripts. So we're going to go to the desktop and data shell, and we're going to go into the molecules directory. So desktop, data shell, molecules. And inside of here, we have our PDB files. I'll remove this text file. So we're going to create a script which is going to take the middle lines of the file. So I'm going to create that script using the nano command. We're going to give it a descriptive name, so middle, because we're getting the middle of the file. We're giving it the .sh ending. Now this again, this is for our information, so we know that it's a shell script. Bash doesn't care, so we could just call it middle and then run that, and Bash will be fine with it. But in this case, so that we know what it is, we're going to call it middle.sh. And so we'll press enter, and nano gives us this blank page. So we're going to start off, and we're going to create the exact command that we want to test. So head -n15 octane.pdb and tail --n5. So this will take the top 15 lines of the Octane file, and it will then take the last 5 of those. So we're going to save that, Control X to exit. And do we wish to save the modified buffer? Press Y for yes, and press enter because it's going to be middle.sh. So we have got now this script which has this command in. To run this script, so we have that script, head -n15 octane. To run it, we simply use the bash command. If you're on, now you can use bash, you can use ZSH if you wish, and if you're on OS X and your shell is ZSH, you could use ZSH. But that will run it, and it gives us that output from Octane. So those are middle 5 lines. So that's very helpful. You can now give that to a colleague and say, here you go, this is my script, it gives us these outputs. That's very helpful. But we'd like to make it a bit more functional. Maybe you don't always want to work on Octane. So we're going to change this script so that it can take arguments. So we're going to edit it again. So nano middle.sh. Now, instead of using Octane here, we're going to pass it a variable. Now, this is a special variable. This isn't a named variable as we were looking at in the loop example. What this is a variable which is being passed to this script. Now, the script will, when we run it, it will check for any arguments after that script. In the same way that list or copy or move look for arguments at the end of a command, this will look for arguments after that script, and it will pass that argument, take that argument in, and run this command on it. So we're going to save that now. So we save this modified buffer, and we can see here we have head -n15 $1. So that's taken the first variable. Now, if we run that, what happens is that it says, okay, we haven't got this. Because we haven't passed an argument, that's just empty. And so the script will carry on trying to do something. It passes that empty object to head, and head says, sorry, I don't know what to do. But we can now pass it Octane. And it gives us the same result as we had up here. So then we can try it, say, on Ethane, and we get a different result. So we can now see that this is usable for each individual file, any file that we wish to process. It's always good to start off with a command you know works, then make a change to start making it more generic. Test that generic command on a script that you know, on the original object, so that you can compare and make sure that it gives you the same output. So one of the habits in software development is to prototype your script. You then will have a process of refactoring it, where you make it more generic, where you make it more streamlined, more operable. So what we will do now here is try to make it more functional, so that we don't always take those middle 5 lines, so that we can change how many lines we're going to pass. So we're going to run nano middle.sh. So we're going to now look for other variables. So we're going to look for $2, and we're going to look for $3, or variable 1, variable 2, variable 3. So each argument that's getting passed, we're going to look for that argument. So this script will take 3 arguments. And we're going to save it. And we're going to save it as middle.sh again. So so that's our new script. And to run this, we will Octane, and it's always good to run the original command to make sure it gives you what you expect. And this is what we expect. That is the same command there, same output here. So now we can change that and see that we get different output. So that is a very useful way for building a script which is very functional. It's very flexible, so you can do with it as you wish. To make sure that when you come back to this in a week or a month's time or 3 months' time, you want to add comments to that script so that you know you have documentation. Now, you can add in quite complex documentation. We're not going to do that today. What we're going to do is just add some comments. So if you just press enter at the start of that line to move it down, you can then create a comment line. This will be started with a hash symbol. If you're on Mac, you get the hash using Alt-3, because the UK Mac keyboard doesn't include a hash symbol on it, which is easily accessible. And I think this is Apple's way of kind of adding an extra impediment to software development in the UK. So reduce competition. So we have got select lines from the middle. So you want to say what the script will do, and you want to give usage for that script. So you want to show how it should be used, what you expect. So you expect a file name, if I can spell it. You expect the end line, and you expect the number of lines. So that's kind of useful. I mean, you might need to think a little bit about which the end line should be, but it's better than nothing. So both of those lines should start with a hash so that Bash doesn't try to use them. That Bash will just look in it and go, okay, I'm meant to ignore these, I'm going to ignore them. You could, if you wish, add a comment here too, so you can comment after a line, and anything after that hash will be ignored. That does get quite unreadable though, so I don't recommend doing that. I would always have a comment on a separate line. So Control X to save that. And I'm going to save that modified buffer, and we save to file name. Yeah. So clear, and I'm going to cat middle.sh. So you could now give that command, that script, to a colleague and say, here is my script for getting the middle of a file. They can look at that information and work out how to use it. And you get information here about what arguments you're expecting. And you can go into as much detail as you like. If you have lots of arguments, if you have optional arguments, you could then expand that information. So, so we can do similar. So we are going to create another script now where we want to look at word counts and sort those. And we're going to create a script which can take a range of arguments to sort these files. So we're going to create a script called nanosorted.sh. Now, the command that we're going to enter, so this is our prototype, if you like. I'm not going to go through and run this each time, but this is the kind of command that we want to do. So we want word count to operate on a set of files and sort those, give the line length for each of these, and then we're going to pass that output to sort, which is going to order numerically. Now, we couldn't pass star.pdb as a single variable. Indeed, if we want to pass extra information, so we could pass extra information like this. Now, we wouldn't say $1, $2 here. What we want to use instead is a special reference, which is $@. Now, what this command will do is it says, I want to suck in all the arguments that this script is being given. And I'm going to take all of those arguments and I'm going to pass them all to this command here. And all those will be pulled in, and then they will be passed. Then the output of that will be passed to sort -m. So create that script, and we're going to save that. Control X to exit and to save. So we've got this script here, word count, and we're going to take in all arguments. So now if we run that, and we're going to run it on *pdb, we get this output. As I showed you earlier, we can also pass it multiple options. So each of these is getting expanded when it's by bash to then pass through, and they're getting expanded. Those expanded file paths are getting passed to WC. So that now is giving us all these files, counting of those lines, and giving us a total. So there's then extra options there that we can run through. There's some questions about using shell scripts and how to use these now. I won't go through those at the moment. What I would say is that there is a way, if you've prototyped a workflow, you can then get that. So you've prototyped it on the command line, you can then pass that information into a script. So you could take the history command, you could take the last 5 of those, commands, and you could pass those into a script here. And then we're going to edit that script. So this is if you've got that workflow you want to now save it, you can edit that. Now, to make this usable, you would want to get rid of these line numbers. You also will want to get rid of the previous commands. Now, what history does, what bash will do is it saves a command before it runs it. So you would always end up with that extra line, which is the command that you've just used to look at the history command. It does this because you don't want to run a command and then record that you've run it, because you might crash the system while running that command, and you want to look back to see what you were doing. So it always makes sure to save the information about what is being done before it's done. So in this case, you'd then just have to delete that. But that is a way for you to quickly gather up the operations that you've been running and put them into a shell script and then create a working shell script from that. So I'm going to exit that now. So there are a few extra bits in there, which I'm not going to go into. The only thing I will say is that if you do have a bash script which you want to debug, there is this -x command, or flag rather, which will tell bash that you want to run it in debug mode. And what that does is it shows you each command as it's run. Now you'll note that it's waiting here. That's because the sort command has been passed no information. And so it's expecting us to pass that information from the command prompt. So I'm Control-C to kill that, to stop that. But if we pass now these files, that -x shows us the commands that are being used. So we have word count is being passed to all these files, and then sort is working on that. Or rather, sort is being run, and this is our final output. So there is a bit of an option there for a bit of debugging. Bear in mind that it's still not as operable as Python or other debugging system, other languages. They have better debugging systems. Now we have got about 15 minutes. Now there's a question which I will check on that. So I have a question on variables in shell scripts. Right. Well, we won't go through that. One of the things you should be aware of is that having the quotation marks around a string will stop it being expanded if you've got a wildcard in there. Now that only stops the first command from expanding it. So that string, the star PDB, would then be passed into the script and then be expanded by the head and tail commands. So you can pass, if you don't want the original command to expand something, you can quote it and it will be passed as a single string. That's a bit of a, it is very useful. It's not very useful for beginners, but as you become more practiced using bash scripts, there will be times when you need to use that, and that is a useful bit of information to you to know. But what we'll do now is I'll just move on to the last lesson now. We have 15 minutes left, so I'm not going to, or rather 10 minutes left. I'm not going to go into great depth on this, but I'm just going to give you a quick introduction to grep, which is a way of finding items in files. So this is just another little tool which is very useful within the shell environment, and it allows you to search for items. So I'm going to clear this, and we're going to go to desktop data shell writing. Now grep is for is a tool for operating on text files. So we're going to look at some text files that we've been working on. So here we have got haiku.txt, and that file contains these haikus. So if we wanted to do a little bit of analysis, see what is in this file, say how often the word not appears, we can use the grep command, grep. And we're going to search for not. So first argument is what you're searching for, and the last argument or arguments is going to be where you're searching. So here we're looking for not within haiku, and so we've got not here, and we've got a not there and not there. So it returns each line which has that string. Now, we could also search for the, and this gives us the town that is seen and my thesis. So it gives us those characters wherever they are. It doesn't care if they're a whole word or not. Also, it doesn't return lines like this where it's a lowercase. So there are options that we can, flags we can use to change that. So first, we can use -w to make sure that we are only identifying a single word. We can also add in -i, which is to ignore case. And so that will return multiple, that will return the, whether it's all lower or it's got uppercase as well. Now, if you wanted to match multiple words like these or is not, we can again use the quotation marks to indicate that that is a single object or a single argument for grep, and it will find that example there. And the last little example I'll show you there is -n gives you the line number. So today it gives you that line number, and you can also have the reverse, so you can return everything except that line. Now, there are a few extra options. Grep has lots of help. And if you're on a Mac, you're not going to see much information there. You can use man grep. If you're on Linux or Bash, Git Bash, you might see a lot more information about the different options you can use. Now, the other one last thing I'll show you on that is that you can use wildcard. So we have got grep. I'm going to use -e. So this is extended regular expressions. There are in the library Carpentries, there is a really good lesson on using regular expressions. So the question mark to indicate a single character, or the star to indicate 0 or more characters. In this case, we're using a dot to indicate a single character, any character, because this is slightly different notation for a regular expression. And we're using the hat symbol to indicate the start of the line. Now, the library Carpentries have a really good lesson on how to work with regular expressions. And if you're doing any work with text, these are good to learn. They're painful sometimes, but they're really powerful and useful for searching through text files. So in this case, what this does is it identifies each line which has 0 as the second character on that line. And you can use this to create any set of commands you can match to the end of the line and so on. So there's some really powerful operations that can be made with regular expressions. I recommend looking up that libraries carpentry lesson and going through those lessons. And the last command that I'm going to show you, so there is more, go through the course material. We didn't have time to cover everything, but I recommend having a look through those. The last command I'm going to show you is the find command. And this, if you aren't quite sure what you're looking for, you can use find, and this will show you everything within a certain location. So in this case, we're saying we want to see everything which is in my current directory. The dot is the current directory. You can say, I only want to find the directories within this space. So that's type D. So this is an argument to find. It's not, so it isn't, it isn't actually a flag, it's an argument which is being used afterwards. So this is minus type D. This will find all directories. Or you could find files. So that is a very useful command for trying to process or search your operating system, search your file system. And you can also then, you can pass in more options. So we can say, so I'm using the quotation marks here to stop bash itself expanding that wildcard. So what we're going to then allow is the find command to expand that wildcard. And so that then finds haiku, and it finds text, little woman and one.text. I'll just show you what happens. So if you don't, as I was saying previously, you can just, if you add quotations, if you don't add quotations, it will be expanded automatically by bash. What happens here is that this command has been automatically expanded, and it's been expanded to match what is in this directory. So we need to stop it from being expanded. It's going to be operated on by the find command. So I'm going to leave it there. There is more that we could go into, but and I will show you actually what, just before I leave it there, there was questions about piping information into the for loop. This is another example of how you might use a shell. So a subshell where you carry out a command and then you pass this into another command. So we're going to get the word count for each of these. Now, if I was to pipe using the pipe command directly, word count will tell me that I've got 4 items, 4 lines. But if I use this command, what happens is that word count will see those as 4 files it needs to process, and it will process those files. So here we then have the word counts for those. So that's a little taster of how you can use subshells, this subshell command, to create quite complex operations simply. So I think that's everything I want to cover now. I'm not going to go through any of the questions. I recommend having a look at the course material, maybe have a look through some of those lessons this afternoon. Are there any questions about those last couple of items which I've quickly gone through?
I have a quick question, if that's okay.
Yes.
So regarding your passing variables to a shell script with the $@ symbol, if you wanted to give it, I don't know how to say it, but like some variables that you knew what they were going to be, and then a list of kind of everything else, would you do 1, then 2, then @ Does it work like that?
Oh, now that's a good question. I think probably, now probably I wouldn't directly do that, but what I would do, so if I if I nano word count dot text. Ooh, now how would we do that? I think this example isn't going to quite work. Here we go. So we've got word count, which is that $at. Now, if I edit word count, I think what I would do instead is I would save that. So I'd say array equals $at, and then here, now we can, now how would I index that? So you can add indexing. Let me bash advanced. Because we don't cover that in this lesson. I do cover this, or I did cover this in an advanced bash lesson, which I've made notes for, but I've forgotten. Most of my coding, I actually use Stack Overflow for coding because I work in so many different languages. I can't remember the notation for every one of them. So what I do is I have my notes, which I work from. So I will research IT, research and bash. I will look that up and I'll put it in the notes. So, where are we? I do have, there we go. I will put a link to that advanced lesson in the notes. So I'll put an extra reading link in the notes, which is the advanced there now, variables and arrays. I would reference it. So you can reference all of the array like this. Now you can also return the number of arrays. So I think what I would do, you could probably construct an argument where you say, I want everything but the last, or I want the first couple. So you could say, I want 1 and 2, I can't remember quite how. And then you would say after here, you might use everything after that. The notation is more difficult, but it is possible.
I think that's all I needed to know. Thank you.
Okay. Have a look at the variables and arrays lesson in that extended bash, and that has a bit more information on how you might do that. Okay. Any other questions, tests for my memory? If not, I will hand back to Alex.
Thanks very much for that, Doug. I hope we managed to convey how powerful Shell is. So it has a programming language on its own, so you can do quite powerful programming within Shell, as we will see tomorrow when we start doing Python. Many of these things you can do from higher level programming languages, such as Python. So if you need to loop over a number of files, you can do that from Python as well. And it's a matter of a design decision how you actually do that. But the important thing for you to know is that you can create complex pipelines from within a shell alone. So with that, I think we can finish a bit earlier, 10 minutes before the schedule, and we'll see everyone tomorrow at 9 o'clock.